Container most water. You are given an integer height of length n. There are n vertical lines drawn such that two endpoints of I line are I comma 0 and I comma height of I. Find two lines that together with the x-axis form a container such that container contains most water. Return the maximum amount of water a container can store. Note that you may not slant the container. So basically, they have given you a graph and their heights. Okay, and in this height, like they have given this 18625,483 is the height array which they have given. So let me see whether I can draw this way also and show you. Okay. Maybe next time. Color wise, let's take this and draw this. Okay, so they have given you the pointers with the height array, which is 186254837. Now, what does this indicates is we have to find the area. We have to find the area. Area is equal to height into width. This is a simple formula of the area, that is h into width of that. So basically maximum area we have to find. So we have to find the maximum height with maximum width. That's the formula, right? They are telling us to find maximum storage of water. How much max water you can store in, consider this as a container, and how much this can be stored, how much this can be stored. So in this format they are trying to ask us like, just tell us how much maximum water can be stored. So for that to know, we need to find out the area. We need to find out the max area. So max area means max height and max width. Okay, now let's try to understand like how we can do this with the brute force approach. What will be your brute force approach to do this particular sum? Basically, we will have a left pointer. Like, let me take another color so that we can understand it better. uh, let's take green. Okay, we will, okay, why not a comment? I don't know. Okay, leave it. So we'll have a left pointer and we will have a right pointer. Now when these are the two pointers we have, brute force approach, I'm talking about brute force approach. So in this brute force approach we have to see height of each, like we have to see the height of this, area of this, we have to find the 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 area of this, then again we have to find the, yeah, now the color is coming, right? We have to find the area of this. Okay, you're not trying to understand, let me give you like the brute force approach so that we all are at the same page. Okay, so this is a vertical line which we have it. Okay, and here is 1 8 6 2 5 4 8 3 7. Okay, and the heights are given according, like the height is up to 1, then it's up to 8, then it's 6, then it's 2, right? And then it's 5. 6 should be a little bigger. Then it's 4, it's 8, it's 3, and it's 7. Okay, so brute force wise, we will have first a left pointer and a right pointer. So So left pointer is over here and the right pointer is over here, right? Now we have to find the area of this height. Okay, so over here the height is 1 and the width is also 1. So the area we get is area equal to 1. We can give a variable as max area. So let's take this as a max area. Max area is 1. Now next height is 1. Again, it's 1 only, right? Because more height is not there. Only width is increasing over here. So the height is 1 into 2 because width is 2. So we update our max area as 2. Then again we go up to here. Now the height is 2, but area, now the height is 1, but the width and the width is 3. So the max area is 3. Now again we go over here and we find that the height is 1 and width is 1, 2, 3, 4. So the max area become 4. So this way we'll have to find the height till 7. So this becomes one iteration. Next iteration will be we are going to start from the second index. Like, so we started from here, right? So let me draw these lines. Okay, these are the lines, right? And so we have started from the first left. Now the left will be shifted towards second index, and then we have to count our max area from the second index. So now I will count it from this index. But since the height is 6, so my area will be 6 into 1. So I'm going to update it as 6 as my area. Next, again my height is 2, so my area will be only this much. But the width is 2 because 1 and 2. So the max area will be 4 because height into width. 2 into 2 is 4. Next, go ahead and check what is the next. So we are starting from here, right? So what is the next? Again the height is 5, so our area becomes still here, right? Our area is this way. This is our area. So the again max area will be height into width, that is 1 2 3. So 5 threes are 15, so we'll update as 15. So in this way again we have to do till 7. So after doing after shifting left pointer at each index, at the end we will understand what is the max area, which will give us time complexity of O of n square, and it's really very time taking because when I'm explaining, I have to explain each iterations, like from index this, from index this, from index this. So when it is the code is running, it has to do all these things for each iteration, which takes a very much long time, and it is O of n square. So we have to find out some other solution and not this brute force approach. Basic idea is we have to find the max area, and for max area we need a max height and max width. So what when we are taking left and right pointer, we have to consider this point of max area and max height. So let's see how can we solve this problem. So this was a brute force approach which I had shown. Let's see what is the little more uh, by using less time complexity, what is the approach. So we'll have a left and right pointer over here. Again we are making sure, if you see in my diagram, in this diagram we are making sure we are keeping more height. So we consider one point of max area, that is more width. We have considered already that, because for max area we need max height into max width. So max width is already there, so we are at the safest. Now when we are calculating the height, right? So we are calculating this height, right? Now we are calculating the height between these two, right? Left and right pointer. What will be the height? If you see, the height is this much, right? What will be the height? that will be 8. I think this is a 7, right? The last pointer is 7, so this is 7, right? And this is also 7 because we have to take the height only. So 7 into 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. So 7 into 7, that is 49. Max area is 49. We got this max area as a 49. Wait, we have to find out now which one we have to shift, whether we have to shift or left or right. We have to decide it, right? Now whichever is lesser, that we have to move. So let's see, what is the left height is 8 and right height is 7. So we have to shift the right towards left. Whichever is lesser, we have to move that. Why we have to move? Because we need a more width, right? That constraint of more width should be there with us. We'll see if we shift the left pointer, we're going to accommodate the less height as well as the less width. So whenever there is a lesser height, we have to shift that so that we get a more height, because we already have more width in our bucket, but we don't have more height. That's the reason we are shifting the right pointer, since it is pointing towards lesser height. So now we'll move over here and we'll count the height of this particular bucket, of this particular container. Over here the height is 3 into width is 6, so 3 6 are 12. We are not going to update it because we already got our max height. Next, again, we will compare the left and right pointer, whichever is lesser. Suppose right is lesser, we have to shift the right. We are shifting the right towards this, and I see that here the height, here the height is 8, and here is also 8, right? So let's count. So let's count 1, 2, 3, 4, 5. 8 5s are 5s are 40. So the max area is 40, right? Max area is 40, which is not greater than our max area. So we are not going to update it. Now again, when heights are same, it doesn't matter which one you're moving it, because our formula is whichever is lesser height, that we have to move. But here, since they are the same height, it doesn't matter if you move left pointer or right pointer. Okay, then we'll move the left pointer. If we move left pointer is at the 6 height, so we will have this much area. And so 6 into 1 2 3 4, 6 fours are 24. Again we have max as 49, so we don't have to move. Which is the left is less, so let's move the left again ahead. Next height is 2. If you don't see the color, let me make it again this color. Okay, so the left height is 2. Sorry, we are here till here. So the left height is 2 1 2 3. The 2 3s are 6. Again it's a less height. Left is again less, so we are going to move the left only, and we are reaching over here. Now the height is 5. So 5 1 2 5 2s are 10. It is lesser. So in this fashion we are going to do it, and we will reach till here, wherein there will be an endpoint, because we have already calculated it, and we understand that the max area always remains is 49, because it has a max height as well as a max width. So the formula to solve this problem is max height and max width. So to give you one more kind of an example, like suppose we have a heights array, and here it is 1, okay, and take this as a 5. This is a left pointer, and this is a right pointer. Sorry, this is height of 1, this is height of take it 3, this is height of 4, this is height of 2, This is height of 5. Okay. Now this is a height of 7. Okay. Now when I'm taking left pointer over here, you can see I'm calculating the max width is already there. There is a max area which we are going to calculate. So what is the area for complete this length? What is the area? So one width we'll count it 1, 2, 3, 4, 5. Okay, 5 into 1 because the height is this much. So the water will be filled up only this much. If you try to fill more water, it is going to spill off. So the height becomes 1, 2, 3, 4, 5. 5 into 1 is 5. Now which one to shift? We have to take a decision. Suppose we are shifting the right pointer right over here. So when we shift the right pointer, take an example. We don't have to shift right pointer because our formula is always lesser height should move. But I'm just trying to help you why we are doing lesser height moving the pointer. Why? So I'm trying to solve that query. So when the right pointer is over here, right? We will have the less height only and also will have the less width, so it's of no use. Suppose tomorrow height becomes zero point 0.5. If its height becomes zero point 0.5, then we are just going to decrease more max area, more area will be decreased and we won't get that benefit of finding max area. That's the reason we are moving the left pointer ahead, so that we are counting max area at least and we'll have the more height. We'll, because here the height is less, right? You see, so our formula is max height, and in this we don't have max height, we have a less height, so we have to move our pointer ahead to see whether we get a more height and more width so that we can solve this example. I hope you understood why I'm shifting the lesser pointer ahead. It's not about left and right, it's all about lesser pointer should move ahead. And time complexity wise, because we are going to iterate this only once, it is O of n, and I'm not using any hash map data structure to solve this problem. So that's the reason the space wise space complexity will be O of n only. Let's solve this problem. We need a max area which is an int. It's most, and in the sum they have given heights array. So first thing first, we need a variable in max area equal to 0. We need to define the pointers. Left is at 0 and right is at heights dot length minus 1. While left is less than right, while left is less than right, whatever is shorter, we are going to calculate the current area, right? So in currarea, how to calculate the current area? Max height, we need current area, whatever the current area is we have to check. So when you see current area over here, when I calculated this particular area, when I calculated this particular area, I've not taken the bigger height, I've taken the minimum height. So I have to take minimum height versus more width, right? So let's take that minimum height of left, heights of right. Into width. How we are calculating width? Right minus left. That's very easy. So this becomes our current area calculation. Okay. Now how to calculate the max area? Max area will be Math.max of same thing. Max area will be max height into max width, that I have discussed. So current area versus max area. We'll find whichever is the max area between the current area versus max area, because we are going to update our max area. Whatever height we are getting, we are just going to update that variable, right? So when we are calculating max area, we have to compare with whatever the original current area we have versus whatever we have already stored in the variable. Now, to take a decision, right? If left is less than right, left height, okay? If heights of left, let me mention correct way, and heights of right. Then which pointer we are going to move? We are going to move left pointer, or else we are going to move right. And time complexity wise, it is O of n, because we are just iterating once. Space complexity is also O of 1, because we are not using spaces. So thank you for watching.